Thank you. My name is Bill Simpkins. I'm a professor of hydrogeology in the Department of Geological and Atmospheric Sciences. Our speaker this evening, Dr. Stephen Osborne, is also a hydrogeologist, and perhaps that's a first for this series, so I'm particularly pleased to introduce him. Stephen is an assistant professor at the, I get this right, California Polytechnic State University? California State Polytechnic? Oh, okay, all right. In Pomona, California, where he's been actually amazingly since last fall. And prior to that, he did a number of things. He has a PhD in water resources and hydrology from the University of Arizona and actually got his degree in hydrogeology. He actually has a master's in geology from UC Riverside. Prior to that, he did 7 years of consulting. Prior to that, he has a master's in soil science from UC Riverside. And then prior to that, he got a degree in environmental science from Georgia State University. So he has a long and varied career. And his interests are water quality, subsurface microbial processes, water-rock interactions, and energy in the environment. So he has quite a breadth of stuff there. Why are we here tonight? Well, Stephen's here because we're going to talk about, and he's going to talk about probably the biggest emerging energy thing on the horizon, namely shale gas. And in case you haven't heard, right now, 23% of our natural gas comes from this source of shale gas, and they project by 2035 that we'll have 49%, nearly 50% of our gas coming from that source. Because of this huge glut that's on the market, and with all the gas being supplied, the natural gas prices have gone down to about $2.60 per million BTUs, which not long ago was about $14. And that, in effect, is slowing a lot of the enthusiasm for renewable energy, both in the Midwest and elsewhere. Industry has estimated that we have about a 100-year supply of shale gas in the U.S., which is equivalent, according to Stephen Colbert, to about 2 Saudi Arabia's worth of oil reserves, or a side order of tater tots from Sonic. At this very minute, power plants across the Midwest are actually thinking about moving to natural gas, which would be an environmentally friendly decision since about 55% of CO2 per unit energy, 55% of coal's CO2 per unit energy is actually produced by natural gas, and it also has fewer air quality issues. But as a result of this choice, we have many other environmental things, and there's no environmental free lunch in this business, as with most energy sources. Because of the method of shale gas extraction, somehow in that bargain that we did, we got the Halliburton loophole, which effectively exempts fracking from the Safe Drinking Water Act, the federal statute that protects aquifers supplying drinking water. And drinking water problems were first highlighted in Josh Fox's movie Gasland, although it was anecdotally reported there and elsewhere. Into this fray stepped a newly minted PhD student, Stephen Osborne, who, along with colleagues at Duke University, actually provided the first scientific evidence of drinking water contamination by methane in fracking operations associated with the Marcellus Shale in Pennsylvania and New York. And that was published in the May 2011 PNAS paper shown here. I did bring props. Okay. The response to this paper from the oil and gas interests was swift, including some very pointed letters to the editor in PNAS, which you did respond to, and also a December 2011 paper in Oil and Gas Journal entitled Methane in Pennsylvania Water Wells Unrelated to Marcellus Shale Fracturing. And this was sent to me, highlighted by a former graduate student of mine, telling me which parts to read here. Okay. I think Stephen probably feels more like a present-day climate scientist than a real hydrogeologist as a result of all this. So we're really pleased that Stephen's here tonight and to share the results of his work. Just a note, he's talking in my energy and environment class tomorrow at 11 o'clock, and we'll get into some of the more juicy issues involving doing research in controversial energy issues. And then he's also giving a talk in the geology department at 410 in room 152, Science 1, in which he'll talk more about microbial methanogenesis and a few other topics. So without further ado, let's welcome Stephen.
Wow, thanks for that great introduction. I've had tater tots at Sonic, and maybe that'll be my next research project. Who knows? I want to begin by thanking the Committee on Lectures in the National Affairs Series and the Department of Geologic and Atmospheric Sciences for hosting me. I'm honored to be here, and I'm grateful that you guys have gone through all this weather to be here. I promise I did not bring this with me from California. It was 80 degrees yesterday before I left. So So the title of my talk is going to be Hydraulic Fracturing, Potential on Impacts on Drinking Water. And I begin with this slide. This is a picture of an organic-rich shale. It's commonly known as a black shale. And this is really the target of a lot of the oil and gas industry people. This is what they're targeting in terms of a source for natural gas. And this is what they're actually fracking. As Bill mentioned, I published a paper this last May titled Methane Contamination of Drinking Water Accompanying Well Drilling and Hydraulic Fracturing. And this was published in the National Academy of Sciences, or the Proceedings of the National Academy of Sciences. I want to acknowledge my co-authors, Avner Van Gogh, Rob Jackson, who were my postdoc advisors, and then Nathaniel Warner, who's a PhD student under Avner Van Gogh. And there's funding that came from Fred and Alice Stanback and the Center on Global Change at Duke University. So just as a brief outline, I want to start off with an introduction and motivation to the research. Then I'll move into presenting some results from my Appalachian study and conclusions, and then talk a little bit about some recommendations and observations that I made during field work and observations that came out of the results from this paper. So one of the first questions I would get from homeowners as I came onto their homes and asked them if I could sample their wells is, why Duke? And it's an important question, but Duke is down in Raleigh, North Carolina, several hundred miles south, and there were several concerned homeowners that live in northeast Pennsylvania that had some affiliation with Duke, that actually made a phone call to the dean of the Nicholas School of the Environment the same week that I arrived there to start my postdoc. And I had done my dissertation work in the same area, sampling oil and gas wells in New York and Pennsylvania. So this project sort of fell into my lap, and it was very serendipitous. But importantly, North Carolina has, importantly, North Carolina has natural gas resources, and the state legislature is actually struggling with how to proceed in allowing hydraulic fracturing from occurring within the state. No. Oh, there we go. I checked the wrong connection. But anyways, before I left, I actually co-authored a op-ed piece in the Raleigh, the News and Observer, which actually got picked up in the Charlotte newspaper, where we drew an analogy between pig farming and shale gas. Back in the 80s and early 90s, hog farming in North Carolina expanded significantly, and there are associated environmental impacts to that weren't originally accounted for until later. And so we wanted to draw that analogy and try and take lessons from what was happening in, say, Pennsylvania and other parts of the U.S. Before we proceeded in allowing hydraulic fracturing to occur in North Carolina. But it's not just about North Carolina or Pennsylvania. There are shale gas basins all over the U.S., particularly east of the Rockies, all throughout the southeast, and of course the Marcellus up in the northeast and Great Lakes regions. And what's important to take away is that the technology that's being used for hydraulic fracturing, it's combined with horizontal drilling. This has allowed exploration of areas that once were not targeted for natural gas extraction. So it's expanding significantly in many parts of the U.S. The area that I did my research in northeast Pennsylvania did not have a whole lot of oil and gas in it. Most of the oil and gas was west and central and western parts of Pennsylvania. But they experienced a significant increase since 2000 in natural gas drilling. So my study was done, as I mentioned, in the northeast parts of Pennsylvania and two counties, Susquehanna and Bradford counties. There is a town there called Dimmick that many of you may have read about. that has been in the news because of the idea of stray gas or stray migration of methane associated with natural gas drilling. And so we went into these areas, not including Dimock, but also in surrounding areas in Susquehanna and Bradford counties, sampling homeowners' wells. Now, the argument for shale gas is that it's an important resource. Since 2000, this graph here is taken from the Energy Information Administration, and what it depicts is gas production in billions of cubic meters since 2000. And from 2000 to 2010, we see a ramping of production of shale gas. And it's expected, the expected trend is that shale gas will take a much higher proportion of natural gas resources production in the U.S. going through 2040, as Bill mentioned earlier. This is a graph of the number of wells that have been drilled in Susquehanna and Bradford counties. The red represents Bradford County, and the blue represents Susquehanna County. And since 2000, there's only been maybe a handful of wells drilled in either county. In fact, there have been no wells drilled in Susquehanna County until about 2007. But what you can see is starting in 2007, there's a significant increase in both counties in terms of the number of wells that have been drilled. And this is only a fraction of the number of permits that have been applied for and issued within the state. So these are actual well completions. And so you can see that at least in Bradford County alone, there's in 2010 there was almost 400 wells that have been drilled. And we'll see in a moment that was in a fairly small part of that county. Now, in 2007, it's important because there was a company called Range Resources in New York. They drilled some wells in the Marcellus, and they fracked it, and they got some amazing production numbers, which renewed interest in the Marcellus as a natural gas resource. And since then, there's been lots of companies going to these areas, trying to lease up properties and drill wells. So it really began in 2007, and that was actually right after I did some of my field work for my dissertation work. So just briefly, a little bit about hydraulic fracturing. It combines two technologies, really. There's the idea of hydraulic fracturing where you inject very large volumes of water. It was reported in the Marcellus upwards of 5 million gallons, 5 to 7 million gallons even, at very high pressures. And these waters are chemically treated to react in the subsurface. The other technology is horizontal drilling. This allows the companies to intersect more of the organic rich shale formation and extract more of the resource. So this combination of technologies has really expanded hydraulic fracturing in a lot of areas that once were not targeted for natural gas extraction. I also want to point out, actually, before I move on, that it's intended to stimulate the flow of fluids in the subsurface in the zone of interest, and that would be this shale formation that they're interested in. They frack it, they open up new fluid flow pathways, and again, it's intended to stimulate fluid flow in that zone. The recipe and the technique can change depending on the company, depending on the geologic conditions, so it can be highly variable. So the case for hydraulic fracturing has been made that it's a clean burning fuel. And in terms of the environment, the argument is that they do this in such great depths that there isn't any possible way that the migration of fluids from depth could occur in these shallow groundwater systems. In this figure, this is taken from the Energy in Depth website. This demonstrates that, at least in Pennsylvania and in New York, the Marcellus can be upwards of 6 to 7 or even 8,000 feet deep. So it's a fairly significant depth geologically. And they also put just for a little bit of scale, they put the number on the left side. That's the size of the Empire State Building, which is particularly apropos for New York State. So you can see it's seven or eight different Empire State lengths deep, which represents a fairly significant depth. But it's important also to point out that at least in this area, the geology is very complex. This part of the country has experienced 4 different mountain building events. In other words, continents clashing into one another. And what that's done is that's created a lot of deformation in the subsurface, fractures, lineaments, faults, and whatnot. And so there are many, there are lots of conduits for fluid flow to the surface, and these are documented in the literature. So this is a picture that I took from one of the homeowners that I sampled with, and this is a typical. This is what you would typically see. You can see there's lots of machinery and earth-moving equipment, and these rural roads often are just dirt roads, and they get tore up by a lot of these machines. This represents a lot of noise as well. And to the credit of the operators in these areas, they try very hard, to my knowledge, to abate those issues. They try to keep track of the roads as best as they can. In fact, many cases they actually improve the roads from after they are there from for what they once were. In this case, the homeowner, this was taken right from the guy's front porch, the homeowner's front porch. So can you imagine having this right next door? He complained quite vociferously about the noise that was occurring, and the operator who operated this actually built a wooden fence to help abate that. That still didn't help a whole lot, but it satisfied the homeowner enough. So in most cases, the operators here try very hard to leave a small footprint as much as they're able to, given what you see here, and improve the roads once they leave. But there are still some issues that do occur and that are documented. This is a picture that I took, again, from somebody's front porch of one of the gas wells that was drilled right next to their property. What you see here is the actual well right there. And it doesn't look like a whole lot, but these wells, when they get overpressured, they vent often throughout the day. You have tanks right to the side over there. And a lot of people who live there, they complain about that it's an eyesore. You can see that the scenery is quite pretty there, actually. And so it becomes an eyesore. So there's lots of ancillary issues that are involved with this shale gas. But I think one of the most important things is that they actually vent quite often throughout the day. They vent methane to the atmosphere when it gets overpressured. And some of the homeowners complain about different respiratory ailments as well. I'm not a doctor, so I can't verify that, but it becomes an issue with homeowners that live in this area. Now, I lived and grew up in California, and it's easy to forget that when you turn that faucet on, you expect to get clean water out of your faucet. If you live in a lot of these rural areas, and many of you probably know this, you rely on your well water for drinking and watering your lawns and feeding your livestock and whatnot. But a lot of the homeowners in Pennsylvania, it's the same situation. They rely on their well water for their livelihood. And when they observe a noticeable and tangible change in their water quality, they become concerned. So this is an advertisement. If you drive around Pennsylvania in these areas, in Dimock, in Susquehanna County, in Bradford County, you'll see billboards that look like this. You'll see billboards that are in favor of hydraulic fracturing as well. And this is reported water. This is reported to be water that is taken directly from a homeowner's faucet right after hydraulic fracturing occurred next to their property. And it raised an important question. Would you drink this water? I don't think I would. I would be concerned if I saw this. So these homeowners, they see a notable and tangible change in their water quality. The color changes. They see it effervesce like Alka-Seltzer. You put Alka-Seltzer in the water. And whether you believe this is true or not, the homeowners are very well connected to their water quality. The most striking thing from the first summer that I sampled to the second summer was they become very, very knowledgeable about their water quality, the science of it as well, and they became very active. So that was one of the most striking things from one summer to the next. So then the question becomes, why should we study the environmental risks? Well, based on that last slide, the question may seem a little bit obvious, or the answer may seem a little obvious. Well, it's really the potential discharge of shallow groundwater systems and the environment from these practices, potentially toxic and even radioactive produced waters. Now, produced waters are waters that come back out of the well. You inject a very large volume of water into the well. Some of that water actually comes out. And it varies from anywhere from 20% to 70 or 80% of that water comes back out. And these waters can be highly radioactive. The brines that occur naturally at depth in the Marcellus have been reported to be upwards of 16,000 picocuries per liter. Now, the EPA standard for radioactivity in waters is 5 picocuries per liter. So you can imagine that some of these waters can have potentially be highly radioactive. These are the brines that occur naturally at depth can be highly saline and have fairly high concentrations of some toxic elements that occur naturally. And these waters mix with the waters that are injected to produce this mixture of different of water quality that comes out of the well. Another obvious environmental risk is explosion or asphyxiation. Methane is, of course, a hazard for fire and explosion. There have been some reported instances of explosions occurring in Ohio, and I think as well as in New York, related to stray methane that migrates into people's basements and whatnot. The other thing is asphyxiation. Methane can displace oxygen in people's homes, in people's basements. So it becomes an issue from that standpoint. One of the things that fell out of this work was when we did a literature search of potential of the medical literature. We asked the question, well, what are some of the health risks if you ingest water that has high concentrations of methane? Well, there really isn't any literature on that. It may be that there is no risk, but one of the things we recommended as a result of this work was that there should be a panel of health officials to look into this more specifically. And the other thing is that there's a large number of wells in these rural areas that go untested and unregulated. And that's important because, like I mentioned earlier, the homeowners rely on these well waters for their livelihood. And when it becomes contaminated to the point that they can't use it, it becomes a very serious issue. If you're a dairy farmer, for example, in these areas, if there's any hint that your water is contaminated, you can't sell your milk in your business. You're done in terms of your business. And if some of you have lived on a dairy farm here in Iowa, you might understand that. So there's a general lack of published research regarding potential environmental impacts. There's a surprising lack of it, in fact, which is one reason why we came along. We noticed this in addition to the homeowners asking us for help. We did a literature search and noticed there's a general lack of published literature that's dedicated to looking for environmental impacts. Most of the literature deals with improving the technology, in fact. But this general lack of research, it precludes a thorough scientific assessment of risks, and is what largely motivated this study. Now, this picture is a picture that I took in front of a homeowner who once worked for one of the operators in that region. In fact, he worked for the very operator that potentially contaminated his well water. He was, I think, a well tender. His well actually, the well he used for his house originally, he couldn't use anymore, and so they drilled a new well, this well right here that we pictured. And oddly enough, this well has lots of high concentrations of methane in it as well. So our research questions, we began with a simple question, which was, are private wells, privately owned wells, in close proximity to natural gas wells more likely to show evidence of contamination, if at all? If so, we wanted to know what is the source of these fluids. This is important because, and when I say fluids, I mean gases as well as liquids. This is important because there can be natural gas that's produced in shallow groundwater systems by microbes. And so we wanted to, in a broad sense, distinguish it from gas that is produced at depth in the earth by thermocatalytic breakdown of organic matter. In other words, this organic matter gets buried at great depths, it gets heated up, and methane gets created that way. And what we see is that the chemistry of the methane, whether it be microbial or thermogenic, we say, it can be different. We can distinguish it from each other. And that leads to the third question, is methane microbial or thermogenic in origin? This is important because if it's microbial, it was probably produced in the shallow zone and exists there naturally. If it's thermogenic, it would have had to have migrated from great depths in the basin to the shallow groundwater system, indicating that these flow paths exist. This is a picture of me sampling another homeowner's well, and that's Avner Vengo. She was one of my co-authors. And you can see, if you look in the bucket there, you can see what the water looks like. It's very black, dark gray color. And this is after pumping this well for, I'd say, an hour and a half. What's interesting also about this is that before we actually got to this well to sample it, we made a phone call because there was a lock on the well, and we said, we need to sample this well, and we got permission from the homeowner to do so. But the lock was owned by the operator, the natural gas operator. And so we said, well, we're going to be there in about an hour and a half. Well, they showed up about 45 minutes before we got there to pump the well dry. They actually did us a favor because they pumped all that formation water out of that well, and it didn't actually go dry. So we were able to get a much better sample of the water. But you can see even after all that pumping, and this of course assumes that this well was installed properly. But you can see after pumping it for so long, the water is still kind of gunked up a little bit. There's still quite a bit of coloration. So we ended up taking about 68 water samples throughout Bradford County, Susquehanna County, and some counties, a handful of counties from counties surrounding these two counties. We analyzed these waters for major elemental analyses of cations and anions. This is important for looking for mixing relationships with respect to salinity. We had also read that boric oxides and boric acid are common additives to fracking fluids. So we wanted to measure boron concentrations in addition to boron isotopes. The isotopes, it was our hypothesis that would have a distinctly different isotopic signature if they were mixing with shallow groundwater systems. So we measured boron isotopes. We also measured hydrogen and oxygen isotopes to try and understand what the source of these fluids are. The brines have a different isotopic signature than the shallow groundwater systems. And in fact, they may have different isotopic signature than the waters that are injected. And then we also looked at measuring radon and radium-226. This, of course, was to try and understand if these brines from depth that can potentially be highly radioactive are mixing in these shallow groundwater systems. So these are the analyses that we conducted in the water and the shallow groundwater. Of these 68 water samples, we collected 60 samples for dissolved gas analyses. And this included gas composition. In other words, what kinds of hydrocarbons are comprised of the dissolved gases, methane, and the higher chain hydrocarbons like ethane, propane, butane. We also looked at the methane concentration in milligrams per liter. What is the methane concentration in these waters? We also looked at the hydrogen and carbon isotope values of methane. This will become important for distinguishing the type of methane. Is it microbial or is it thermogenic? And this is a picture of Nathaniel Warner. He was taking some field measurements as we pumped the well. We were measuring pH, electrical conductivity, dissolved oxygen, and whatnot. And just as sort of a side note, when our paper came out, we got a lot of publicity. You guys may have seen it in the news. But one thing that I've come to understand is that any picture that's published of me associated with this article, it's mostly of my feet. You'll notice this picture. The person standing behind that is myself, and in most cases it's a picture of my feet. And this has happened numerous times with reporters that have come to do news articles on our fieldwork. This is a map of our study area. This top map just represents simply the locations of samples that we collected. You'll note that it's mostly through Susquehanna County. That's where Dimock is. That's the sort of epicenter of this the environmental issues regarding hydraulic fracturing. We also looked at sites in Bradford County. Bradford County actually has more gas wells than Susquehanna County. We also looked in some other counties like Wayne County, Wyoming, Lackawanna, and then we also sampled up in Otsego. We were fortunate to have one natural gas operator that wanted to work with us during sampling, and we were able to get a sample of the fracking fluid as they fracked, and some, or we actually were going to get a sample of the fracking fluid. We weren't able to do that, but we did coordinate our sampling around the time when they did frack, and that was up in New York. Now, these smaller gray symbols represent location of gas wells, and it's peppered throughout the landscape. And you may note that each dot can represent upwards of 6, 7, or 8 wells in one location. So you can imagine there's quite a lot of natural gas wells in New York and Pennsylvania. Now, there's an inset here that's come from Dimock, and you'll see there's 3 towns. There's the town of Montrose, there's the town of Brooklyn, both to the north and to the east of Dimock. And what you'll see is that in the southwest corner of this inset, there's quite a few natural gas wells, those small gray dots. But there's not very many that are occurring to the west and to the north. There's a front of drilling that's moving eastward through this county. And when we were there sampling, this is the way it was at the time that we sampled. And so from this, we divided our sample set into 2 different groups. One group where we have homeowners that are within 1 kilometer of a natural gas well, which we defined as active extraction areas. The next group are samples that were collected from homeowners that were not within 1 kilometer of a natural gas well. This 1 kilometer was sort of an arbitrary delineation, but we'll see actually in a moment when we look at the data that it was actually a fairly good one. So in Montrose, in Brooklyn, we have many samples in areas that have not been drilled. Now, importantly, when we were sampling there, these wells, the homeowners in these areas, most of these areas were already leased up by operators with the intention of drilling. And in fact, since we did our fieldwork here in 2010, many of these homes have actually now have natural gas wells near them and would be classified as active extraction areas. And so as time goes on, we can resample and see what happens with their water quality. So this will be an important theme. We divided our sample group from between active extraction areas, defined as homeowners that are within 1 kilometer of a natural gas well, and then non-active areas. And then and I also want to point out that there's a red dash line that represents a generalized cross-section of this area. And it's very generalized. The geology here is quite complicated. And so this is just collected from information that was available to us at the time. And the one point I want to make about this is that the Marcellus is fairly deep in this region, upwards of 1,500 to 2,000 meters deep, relative to the ground surface. And that's an important point. This goes to the argument that the operators have with regards to it being so deep that there can't possibly be any connection. But we did make the note that there are fracture networks that occur all the way to the ground surface, which may be conduits for fluid flow. This is a geologic map of the area, and these red dashed lines represent lineaments and faults that are known to exist in the area. Undoubtedly, there are more than this that are not in the published literature, but they represent, again, pathways for fluid flow, or potential pathways for fluid flow to the surface. So this is first slide of my results, and what we see is that, okay, so this is on the x-axis is the distance to the nearest gas well in meters, going from 0 to 6,000 or 6 kilometers. And then on the y-axis we have methane concentrations. That's dissolved methane in milligrams per liter. And again, we defined, we separated our data into two groups, the active and non-active. The active being these filled-in gray circles, and then the non-active being the open triangles. And from this, what we see is those wells that are outside of 1 kilometer tend to have fairly low concentrations. It's important to note that 85% of the samples we collected, whether they're active or non-active areas, have some amount of methane in it, detectable methane. So these low concentrations may be considered natural background levels of methane. This gray field represents levels for hazard mitigation defined by the Department of the Interior, from 10 to about 28 milligrams per liter. Of course, greater than that becomes an issue as well, right? So then if we look at the samples collected from the active extraction areas, we see that the concentrations are upwards of 64, our highest was, I think, 64, 65 milligrams per liter. Whereas in the non-active, we had some samples that were several orders of magnitude less than that. It's also important to note that not all of the samples we collected in the active extraction areas don't have high methane. Some do not. In fact, half of ours consistent with the samples we collected from non-active areas. But the other half have high concentrations of methane. Within our study. So this becomes a problem. Some of the homeowners, when we interviewed them after we sampled, we asked them if they had noticed that they could light their water on fire. Can you imagine lighting your water on fire? That's a pretty remarkable thing. But some of them were able to after the gas well had been installed. There was one gentleman who he created essentially a candle, which he ran his water all night long, and he could keep a candle lit off of that. And he put it up right in his front yard for everybody to see. It's quite remarkable. So on average, the active areas were 17 times higher compared to the non-active areas. So what we see is that there's a distinct difference in the methane concentrations that are occurring within 1 kilometer of a natural gas well as compared to outside of 1 kilometer. If we look down at a breakdown, if we look at a breakdown of the methane concentrations, this is simply a histogram of the percent of wells per category that have less than, for example, the first category is less than 1 milligram per liter. In the non-active areas, more than 80% of those wells were less than 1 milligram. And in fact, many of them were on the order of 0.01 or 0.001 milligrams per liter. And that drops off fairly significantly as the methane concentration goes up. Whereas you see in active areas, there are methane concentrations that occur throughout the range of our data set, from less than 1 all the way up to our last category, 61 to 70. So there's a distinct difference between, in terms of the methane concentration in wells from within 1 kilometer and compared to wells that are outside of 1 kilometer. So next we went to look at more deeply at the composition of the gas and the carbon isotopes. Now this is one of three slides that have actual chemistry on it, and this top graph represents it's what's called I'm forgetting the name of it offhand. Anyways, it's methane to higher chain hydrocarbons. And we use this to distinguish microbial methane from thermogenic methane in a broad sense. Since microbes produce methane, they don't tend to produce ethane or propane, some of the higher chain hydrocarbons. So when we take the ratio of methane to higher chain hydrocarbons, we'll see that those ratios tend to be very high if it's microbial gas. In addition, the carbon isotope values will be more negative. So that's what this x-axis is, this delta 13C of methane. Those are carbon isotope values. And so these microbes will fractionate the gas such that the carbon isotope values will be less than about negative 64 if it's purely microbial methane. And the ratio of methane to higher chain hydrocarbons will be greater than about 1,000. Now, thermogenic gas produces higher chain hydrocarbons in addition to methane. So those ratios will tend to be lower, and they have a distinctly different carbon isotopic signature in terms of purely thermogenic gas, whereas the purely thermogenic gas will be less negative than about negative 50. That's represented by the green. There are these gray fields. There are the grayscale data in black and gray. That represents gas data that's collected from gas wells in the Appalachian Basin that's published. And part of that also includes my dissertation work. And what we see is there's a trend in the thermogenic field in this upper figure. And that trend in general, it comes from, as you go to the upper right-hand corner, that gas becomes more what's called it comes from a more thermally mature source. In other words, the organic matter has been cooked at really high temperatures for a very long time, indicating a very deep source. And what we see is the dissolved gases from the samples that we collected, many of them in the active areas plot on that curve, indicating that it comes from a deep source. Additionally, we were privy to correspondence that was made public between the gas operator in this region and the Pennsylvania Department of Environmental Protection, which reported gas isotopic signatures and the gas composition from gas wells that were within that area. And what you'll see is there's an orange field. It's hard to see it a little bit, but it's behind the red dots there. That represents actual gas from wells that were collected, that were sampled next to some of the homeowners that we collected, or some of the samples from homeowners that we collected. And it matched that data. And importantly also, that gas well, or these gas wells that represent that orange field, are reported to be producing from the Marcellus Shale. Now, many of our samples plot off of that trend. You can see towards the microbial methanogenesis curve. There are a lot of complicating factors that are associated with interpreting that. Could be a mixture of microbial and thermogenic gas. There could be other things going on. But in general, there's a distinct difference between, in terms of the isotopic signature and the methane composition between active and non-active areas. Now, this is just some data from, in terms of the higher chain hydrocarbons. Now, remember I said the higher chain hydrocarbons come from this thermogenic gas, the gas that comes from deep within the basin that's produced through the thermocatalytic reaction with organic matter. And in active areas, we have 21 detections of ethane, and even more importantly, we have detections of propane and even butane dissolved in some of these waters. This is a fairly significant, at least in my opinion, observation. Whereas in non-active areas, there's only 3 detections of ethane, where there are no detections of propane or butane. So again, there's a distinct difference in the chemistry. There's a distinct difference in the carbon isotope values as well, indicating that these gases likely came from depth, at least in the active areas. Now, we looked more closely at the isotopic values. This is a plot of hydrogen isotope of methane on the y-axis here. On the x-axis, we have hydrogen isotopes of water. This is important because microbes, when they produce microbial methane, they take a hydrogen from the organic matter. They take a hydrogen from the water. So if it's microbial gas, we would expect a correlation between these two values, such that it would follow this line, this sloped line here. In the Michigan and Illinois basin, where there's noted microbial methane reservoirs, it follows that trajectory. But what we see in the dissolved gas is that there's really little correlation to that line. So there's little evidence that there's a significant amount of microbial methanogenesis occurring in these shallow groundwater systems. And this is consistent with other data from around the Appalachian Basin. So then if we turn to the water chemistry, these are a plot of 4 different parameters: alkalinity, chloride. Chloride's important because it's a sensitive measure of mixing because of salinity. We have sodium and then calcium here. And we looked at, we were able to get historic groundwater data in the Susquehanna and Bradford counties. So we not only compared between active and non-active areas, but we compared it to historic groundwater data that was collected, I think, in the early 80s, before there was any real significant drilling in these areas. And we noticed that there's really not a whole lot of difference either between the active and non-active areas, but also with the historic data in terms of the water chemistry. So we didn't see any evidence in terms of the inorganics and the isotopes for mixing of these different waters. So it indicates that there is perhaps migration of these gases, but not necessarily the liquids. Here we have, this is a common plot that's done, hydrogen isotopes of water on the y-axis, and on the x-axis is oxygen isotopes of water. And what we have here, this black line represents what's called the local meteoric water line. And so if it's water that comes from meteoric water, in other words, it's precipitation, it would generally plot along this line. Now the brines are different. These are evaporated waters. They plot off of that line. And that's important because we can use that as some measure or some measure of trying to understand if there are mixing between these different liquids. What we see, though, is that the data plots along this meteoric water line. It's different than the brines. There's very little evidence to suggest that there is, in fact, mixing between these different kinds of waters based on this data set. So what we concluded from this is that there wasn't much evidence. That's not to say it wasn't occurring, but we didn't see any evidence within our data set to suggest that water was mixing in the shallow zone of these brines or the injected fracking fluids. So then we looked at what are the possible mechanisms. There could be migration of fluids from depth, leaky gas well casings is another, or exsolution of methane from intermediate zone waters, followed by migration to the shallow zone. And what we determined was that leaky gas well casings is probably the most likely and simplest explanation to account for this. There are documented cases of leaky gas well casings. Now, importantly, we did not discount the possibility that fluids or the gases were migrating through the geologic column from depth. But we did say that the simplest explanation were the leaky well casings. Now, some people have taken this conclusion and said, well, this is proof that, hydraulic fracturing isn't responsible, and that's not really what we said in our paper. But again, we emphasize that the leaky gas well casing was the simplest and most likely mode of transport contamination to the shallow groundwater systems. So in conclusion, there really is little evidence of contamination of shallow groundwater from fracturing liquids, brines, or these produced waters. Again, that's not to say that it's not occurring. We just didn't see it within this data set. Next, dissolved methane concentrations are on average 17 times higher in active extraction areas compared to non-active extraction areas. Not all wells within active areas show evidence for contamination. This is an important point. Not all the homeowners are potentially going to have a problem. But if you live within 1 kilometer, you may want the bells and whistles may go off in your mind. Half of the samples that we collected from active areas had high methane concentrations that may be considered hazardous. They were above that level that the Department of Interior identified for hazard mitigation. Dissolved gases from active extraction areas were dominantly thermogenic in character and different compared to non-active areas. The average carbon isotope values were negative 37 per mil. The presence of higher chain hydrocarbons like ethane and propane, remember that comes from this thermogenic gas. And many samples match gas geochemistry from gas wells locally reported to be producing from the Marcellus shale. Samples from non-active areas showed a predominantly mixed bryogenic, thermogenic origin. The average carbon isotope values were negative 54, distinctly different. General lack of higher chain hydrocarbons, and there were only a handful of ethane detections that we measured throughout the entire data set for the non-active areas. More research is needed, utilizing long-term coordinated sampling involving industry, researchers, and homeowners. And the homeowners are an important part of this. We also recommended that review of potential health effects of methane, if any, should be conducted by health officials. Establish stronger baseline data in areas targeted for natural gas extraction. In some of these areas, at least early on, there was very little baseline data that was conducted. And so we need to do this baseline data, collect this baseline data before areas become drilled and fracked. Data should be made publicly available where possible, respecting homeowner privacy issues. Now, what's important is when I first started doing this field work, I didn't expect to be pulled into legal or litigation. And some of the homeowners did not want their data to be publicly made available, or the exact location of our samples. And so that was a little bit of a surprise, but it is important to try and make this data available to scrutiny, but respect the privacy of the homeowners. Many of the homeowners do just want to be left alone. They want to have their well water and be left alone. And we also recommended considering presumptive liability setbacks of about 1 kilometer. What that means is that if there is an issue where a homeowner has high methane concentrations, it's presumed that it's a result of the drilling. Now, in Pennsylvania, they have liability setbacks. I forget exactly what it is offhand, but shortly after my paper came out, they made those setbacks much larger. Now, I don't know if there was a connection, but I know shortly after my paper came out, they made those setbacks much larger, and it made it more consistent with what our results were. And in the end, I believe greater stewardship and more research may ensure a sustainable future for shale gas extraction and improve the public confidence. I'd be happy to take questions. I think there's a microphone in back, maybe.
Yes, there's a mic in the back. Why would anyone have a well drilled in their front yard? Is that because of high leasing bonuses and leasing?
Do you mean a natural gas
and
well?
royalties, or does someone else own that property?
Well, I think it has to do with the money. I mean, a lot of the people that I dealt with in the rural areas don't have a whole lot of money, and so if they have somebody come in and knock on their door offering to give them a check for $5,000 or $6,000 just to lease their property, a lot of people took advantage of that. But subsequently or afterwards, they became sorry when they truly understood what was involved with that. That's a good question. I think there's a question at the microphone.
Okay, it's on there. So what you've described seems to be a very local phenomenon within 1 kilometer.
Yes.
But a larger problem would exist if we got into the fracture lines, the fault lines.
Right.
And so are studies underway to look to see if something that's happening?
Yeah, in fact, my research group, one of the things that we recognized sort of anecdotally that well, there's two lines of evidence. First of all, we saw in some of our data set, we collected a sample from one homeowner that had high concentrations of methane. Their neighbor right next door had very little. And then the neighbor next door to that person would have high again. And that sort of indicated a little bit that there might be fracture flow involved. The other thing that we noticed within our data set, and I think we're continuing to do research on this, is that a part of this is anecdotal. That some of the homeowners had high concentration of methane at 10 and 2 o'clock. relative to a natural gas well. And that has some indication that there is fracture flow involved with that. That's a good question. We'll go to this gentleman, then I'll come back to the mic. Oh,
He said we'll go with you first, sir.
Now, this area has been perforated by hundreds of wells since 150 years ago.
mhm,
And most of those wells were not cemented. They've not been plugged off. They were drilled before there were any regulations. So you've got communication from the Marcellus, and many of those wells were into the Marcellus
Right.
because the Marcellus was
Right.
a potential
right.
objective. And if you're fracking the Marcellus, you can open fractures into those old wells and get communication with
Right.
aquifers near the surface.
Well, that was one of our working hypotheses. First of all, though, that at least in northeast Pennsylvania, that there hasn't actually been a very long history of drilling in that. There are some gas wells that have occurred over 100 years or so, but not like if you go west in the state, say near Lake Erie, near Pittsburgh and all that. That has a much more extensive history of natural gas production. So in Susquehanna County, there's only been maybe a handful of wells drilled throughout this 100-year period. And it hasn't been until 2007 when you had the significant increase in natural gas drilling that has occurred. But you bring up a very good point, and that was one of our working hypotheses, that when you have these areas where there is extensive fracture networks, and these are documented to exist, outside of the fact that you have these old wells, that there easily could be more communication. Yes, absolutely.
A lot of those wells are not documented either.
That's absolutely true. That's absolutely true, yeah. The gentleman at the mic?
Yes, I was wondering, how long are the horizontal lines out away from the well spanning the area?
That's a good question. My best knowledge on that is that it can be upwards of a mile or two even. It can be fairly extensive, yes.
I was wondering if you have any future plans to go to like different shale formations, like such as the Bakken up in like North Dakota, Canada. To keep
Yeah,
up the
actually,
same studies?
I'm thinking about I'm preparing a grant proposal to do that, and we expanded a little bit of our sampling this past summer into Arkansas, in the Fayetteville formation. But yeah, I would like to go up in the Bakken and see if I can do some work up there as well. Yes. One second. There's another.
Have there been any studies on the possible contamination from surface flowback water? You know, when they
Yes.
bring that water back up,
Mhm.
they dump it into pits,
Mhm.
and a lot of that water is exceedingly toxic.
Right.
What are the possibilities of
Well, that
contaminating aquifers?
well, I think that represents probably a more significant fluid flow pathway for a large volume of water. I know of instances where there have been discharges at the ground surface, either by a leaky tank or a leaky pipe or whatnot that have occurred, and in some cases that has represented discharge to creeks or streams that occurred next to the property, and these are documented. Now, it's difficult as a sort of an independent academic researcher to have access to some of these areas when the operator comes in and they clean up a lot of what's going on. So they put a lockdown on a lot of that. So it's difficult to have access, and that's, I think, the biggest problem for academics right now doing this kind of work.
I understand that they aerosolize some of that water with misters,
Mhm.
and they create air pollution problems.
Mhm.
Is that true?
I can't really address that, but I do know there are people that are doing research that we've actually collaborated with, dealing with atmospheric emissions. Yes, in Pennsylvania, not just the groundwater, but atmospheric emissions. Yes, so there is that research that's going on. The gentleman at the microphone.
The slide you showed, there was a drilling straight down vertically and then turns around and
Yes.
sideways. You mentioned the question was asked, you said as much as a mile could be driven horizontally. Simple geometry dictates that drilling straight forward to where you want to
Yeah.
should be simpler than going down and then going sideways.
Well,
What is the advantage of doing that? And the second question related to this is that if you and I are neighbors, when it comes to mowing our lawn, I know where is my property, where is yours. But underground, if somebody is drilling sideways, it just doesn't seem to be any kind of a rationale as to who owns what's underground.
Right.
Suppose I and you are
Right.
a neighbor, one of us wants to sell his right to drill,
Right.
but the other one doesn't, but
Right.
the guy goes out there,
Well,
drills just the same,
right.
gets what he wants without paying you
Well,
anything.
let me address that question. First of all, not all the homeowners in Pennsylvania own the mineral rights under their property. They buy the land, but they don't necessarily own the mineral rights. So the issue becomes a matter of access for the oil and gas companies. They in fact only need one area to get to. You know, they need a public street to drive on, and they need one homeowner within an area to grant access. And once they do that, they can drill in any number of directions. Now, with respect to your first question, the graphic I showed is a very simplistic version of that. But the advantage of going horizontal, and it's important to note that it's the combination of the horizontal drilling with the fracking that has made this so advantageous and has driven a lot of the exploration into new areas. The advantage of going horizontal is that it intersects that formation along a much longer stretch. In other words, they can get much higher production rates as opposed to just going vertical. Does that make sense? So that's a good question, though. At the mic?
I have a bit more of a general question for you.
Yes.
Assuming you would go back to do additional research,
Yeah.
what changes to your research methods do you think you might make, or what else do you think you might want to look into to enhance your research?
Right. Okay, so that's a very good question. I think some of the things that we learned, we need to coordinate with the natural gas operators. And this is important because if what we ended up doing is we just sampled at a moment in time, and that could vary in terms of the fracking any number of ways, right? So we need to coordinate our sampling when a fracking has occurred, before, during, and after fracking for some time period, and get a sequence of samples, a time sequence of samples. I think that would be an important next step. But we need to have access to the homeowners' wells and the information in terms of when they frack. Now, the other part of that equation is to have access to the liquids that are actually being injected in terms of sampling and getting the chemistry of those waters. And that's another important thing. In fact, I would think those are the two most important things: is try to coordinate with the homeowners and with the natural gas operators to get this time sequence of sampling during and after fracking. Thank you.
When you take in the results from your study, do you think you can still say from like a life cycle analysis that natural gas is a cleaner fuel than coal or oil?
That's a very good question. That's a loaded question, actually. Yeah, I mean, it really depends on your perspective. For example, there are people in the industry that argue, well, there still isn't any evidence that hydraulic fracturing specifically is causing the contamination. And I would argue that you have to sort of take it as a whole, you know. If you look at sort of the bigger picture, then there's something going on with the natural gas operations that's causing the contamination occurring. In fact, in a lot of these areas in Susquehanna, the wells wouldn't simply exist if it wasn't for that technology. Now, whether or not it's a cleaner burning fuel in terms of its life cycle, I think that there are probably better people to answer that than myself. But I think that, in fact, there's research going on, even within the research group that I'm collaborating with now at Duke, that are looking at atmospheric emissions. And one of the things that we noticed when we were doing field work is some of the gas wells there are constantly venting methane, or when they get overpressured, they have to vent. And so that may potentially be a significant source of greenhouse gases. We don't know. We're doing that research now.
I want to ask a question about fluid transport.
Yes.
Your study has shown that there's gas transport from the fracking to the surface. Mm-hmm. And would fluids be transported much more slowly and maybe not yet have arrived?
Absolutely.
In the wells?
Yeah.
In the water
and
wells?
This is why long-term sampling becomes important. What we did in large part was a snapshot in time. And so that's the way it was when we sampled. We did another round of sampling this past summer, right before I left Duke. And in general, the results we got from that, although we haven't published it yet, are consistent in general, consistent with our first paper. But there are some differences. Some wells have gone up in concentration, others have gone down. And these are resamples that we've collected. There's a document by the Pennsylvania Department of Environmental Protection. What they did was they had their field people take these FID instruments that measure methane in the air, and they put them over the well. And now, one of the things that they do to mitigate high methane is they open up the water well to vent, essentially. And so they put these instruments to measure what methane is being exhaled off of these waters. And what they've seen is that over time, in some of the wells that have been declared to be impacted, especially endemic, that the methane concentration have decreased. Now, there's some up and down, but overall, over long term, they decrease. They have decreased.
Thank you.
You're welcome. Thank you. Are there any other questions? Yes.
What are the legal implications of homeowners selling leased property to the producers, essentially giving up their rights to complain? Is that true that they don't have the right to complain?
Oh, they complain. There's no doubt about that. They still complain. What they can do about it, of course, is a very different issue. I've heard instances from some of the homeowners that I sampled with where they would physically evict the gas people from their properties. They sign a lease thinking, oh, this will be a source of money, but then when they realize what's really involved, you remember that picture of the gas rig, right, on that next to that homeowner's property, that homeowner. When they realize what's truly involved, they begin to have second thoughts. And there's been instances where they've had to throw people off of their property, even though the gas people had a legal right to be there because of the lease. So yeah, I mean, they still complain vociferously. I think what has happened is that a lot of the homeowners are more politically active. They think that that's their best hope. In a lot of ways. I know there was a news article about how some of the homeowners that have been particularly vociferous within the state politics were placed on a terrorist watch list within the state. And can you imagine? I mean, if protesting something within your state government and then being placed on terrorist watch list. So they were, I think, subsequently taken off that list. Whether they actually were or not, I think, is a different issue. But there were some apologies associated with that and whatnot. But yeah, there's a lot of complaining. What they can do about it is a different issue from a legal standpoint.
Just one quick. This will be our last question,
Yes.
but then feel free to stay for our reception afterwards for further conversation with our speaker.
Yes, sir.
Wondering about reduction in water availability that comes from this. It sounded like you said some of that water remains underground.
Oh, yeah.
And then some of it that comes out is dry.
Yes.
Obviously. So you're taking a tremendous amount of water from
Right.
the environment.
Right. Right.
Replacing it in any way.
Right. Well, that's a very important question. There are quite large volumes of water that are needed. Now, a lot of the operators have resorted recently to recycling this flowback water, this water that comes back out of the well. They recycle it to the next fracking, the next fracking job right now. Early on, though, they would have to treat it. They would send it to any number of treatment plants. Now, I was part of an EPA panel back in February of 2011, where there was a room full of industry people and academics like myself, and I actually asked the question, well, you inject all these waters, these large volume of waters, and obviously some of it stays in the subsurface at very high pressures, and I asked, well, how does the water, what happens to that water, right? Well, and I asked, well, what happens to that buildup of pressure? How does that dissipate? And it was a quiet room. I mean, nobody knew or didn't want to answer that. But that's an important question.
All right. Would you please all join me in thanking Dr. Osborne?
Thank you. Thank you very much.
Again, reception over there. If you have further questions, Dr. Osborne will be around. Thank you. 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 Thank you.